Imagine Earth as a living, breathing organism, an intricate sphere suspended in the vastness of space, pulsing with energy and life. From the silent void, our planet appears both fragile and resilient, a blue marble swirling with endless possibility. Its surface is a dynamic tapestry of land and water, constantly shifting and evolving. Continents drift, oceans churn, and weather patterns dance across the globe, painting a picture of ceaseless motion and transformation. For decades, satellites have orbited above, silently watching hurricanes spiral with immense power, tracking the slow retreat of ancient glaciers, and mapping the vast, mysterious oceans that cover most of our world. These silent sentinels capture the heartbeat of our planet, day and night. These machines, born from human curiosity and ingenuity, gather streams of data that reveal the planet's hidden stories. Every byte of information helps us understand the forces shaping our world, from the atmosphere above to the deepest trenches below. From space, we can detect subtle shifts in gravity and measure sea surface heights with astonishing precision, clues that hint at what lies beneath the waves. These measurements reveal underwater mountains, deep valleys, and even the movement of tectonic plates. Yet deep below, in the crushing darkness of the ocean, mountains and valleys remain largely unexplored, the last true frontier on Earth. The ocean's abyss is a realm of perpetual night, where pressure is immense and mysteries abound. Enter the Xiangyang 01, a Chinese research ship equipped with cutting-edge technology and remotely operated vehicles, or ROVs, capable of diving into the abyss. This vessel is a floating laboratory, designed to push the boundaries of human knowledge. These robotic explorers are our hands and eyes in a world no human could survive, carrying high-definition cameras, powerful lights, and precision drills to unlock the ocean's secrets. They collect samples, map the seafloor, and capture images of creatures never seen before. Here, the worlds of space exploration and deep-sea discovery collide. Technology designed to study the stars now helps us probe the ocean's depths, bridging the gap between the cosmos and the abyss. Chinese scientists, using open NASA data, spotted a hidden anomaly beneath the Indian Ocean, a potential treasure waiting to be uncovered. By combining satellite imagery with deep-sea exploration, they are rewriting what we know about our planet. This journey, connecting stars to seabed, reminds us that science knows no borders. Collaboration across nations and disciplines is essential to unraveling the mysteries of our world, both above and below. It's a quest for understanding that can lead us to the most surprising places, revealing not only the secrets of the deep, but also the boundless potential of human curiosity and cooperation. How can a satellite, floating silently hundreds of miles above our planet, possibly detect something hidden deep beneath the vast, restless ocean? The answer lies in an invisible force that shapes our world: gravity. It's not just a force that keeps us grounded. It's a subtle messenger, carrying secrets from the ocean's depths all the way to space. Earth's gravity isn't perfectly uniform. In fact, it's full of tiny variations. Dense seafloor mountains, made of heavy rock and metal, tug a little harder on the water above them. This creates barely noticeable bulges on the ocean's surface, ripples that are invisible to the naked eye, but not to the right instruments. NASA satellites, equipped with ultra-sensitive radar altimeters, scan these subtle changes in sea level. By measuring the height of the ocean's surface with incredible precision, they can reveal ghostly outlines of the seabed below, almost like seeing through water with gravity as their guide. Chinese scientists realized that metal-rich seamounts would create even stronger gravitational signatures, standing out from the background noise of the ocean. Driven by curiosity and the promise of discovery, they scoured years of NASA and European satellite data, searching for these anomalies over the vast, mysterious Indian Ocean, an area still largely unexplored. Their advanced computer models hunted for the telltale signs of dense, metallic mountains, simulating how these features would distort gravity and leave a unique fingerprint in the data. It was like piecing together a cosmic puzzle, assembling clues from faint echoes in space and whispers from the deep sea. Every data point brought them closer to solving the mystery. Then, after months of analysis, they found it: a specific area on the southwest Indian Ridge, marked by the exact gravitational signature they had been searching for. It was a breakthrough moment. The data pointed to a potential treasure trove of minerals and metals, hidden beneath miles of water and rock, waiting to be discovered. This was more than just a scientific theory. It was a call to action, a chance to turn data from space into real-world discovery. The next step was clear: send a research vessel to the site to see if the clues from space matched reality beneath the waves. The hunt for hidden treasure was officially on. The treasure wasn't gold or diamonds, but something far more vital: cobalt, nickel, and rare earth elements. These minerals are the backbone of clean energy, crucial for batteries in smartphones, laptops, and especially electric vehicles. As the world shifts to electric cars, demand for cobalt and nickel is soaring. Nickel boosts battery range, making electric vehicles more practical. Both metals are also essential for wind turbines and renewable energy infrastructure. Discovering these minerals on the seafloor could reshape global supply chains for green technology. These aren't just rocks, they're the raw materials for a sustainable future. But extracting them from the deep ocean raises a profound question. What is the true cost of retrieving these resources from one of Earth's most fragile environments? The promise of a green revolution comes with a dilemma we can't ignore. A prediction from space is just the beginning. Proof requires a journey to the ocean's depths. The Xiangyang Hong 01 set course for the southwest Indian Ridge, guided by NASA's data. The real challenge: exploring the seabed over 2 miles below the surface. The ship deployed the Heilong 3, a remotely operated vehicle built to withstand crushing pressure. Equipped with American-made robotic arms, the ROV carried lights, cameras, and drills to collect samples. This collaboration of global technology highlights how science transcends borders, even amid competition. The ROV descended into darkness, finally reaching the seafloor. Its cameras revealed a landscape never seen before. The robotic arms drilled into volcanic rock, retrieving core samples. Analysis confirmed the prediction: rocks rich in cobalt, nickel, and other valuable minerals. The whispers from space had led to a real-world discovery. The connection between satellites and seabed was now undeniable. Science had turned a hunch into certainty. The confirmation of these vast mineral deposits has ignited a modern gold rush. This time, not on land, but in the mysterious depths of the world's oceans. For centuries, the ocean floor was thought to be unreachable, its riches locked away beneath crushing pressure and darkness. But now, with new technology and growing demand for rare minerals, the deep sea has become the latest frontier for exploration and exploitation. Once considered impossible to access, the seabed is now a battleground for nations and corporations eager to secure a strategic edge. The race is on to claim the resources that could power the next generation of technology and energy. China has emerged as the clear leader, pouring billions into deep-sea mining technology and securing more exploration contracts from the International Seabed Authority than any other country. Their research vessels and mining robots are already mapping and testing the ocean floor, seeking out the richest deposits. This head start gives China a powerful advantage, raising alarms in other countries, especially the United States, which depends heavily on imports for these critical minerals. The competition is not just about resources, but about who will control the future of technology and energy. The stakes are enormous. Whoever masters deep-sea mining could dominate the supply of minerals essential for batteries, electric vehicles, and renewable energy systems, shaping the future of clean energy and global industry. Other nations and private companies are scrambling to catch up, investing in research and designing advanced machines to harvest the mineral-rich nodules scattered across the ocean floor. The technology is evolving rapidly, with new prototypes and strategies emerging every year. The competition is fierce and largely hidden from public view, unfolding in remote waters and in the inky darkness of the deep sea, a world we're only beginning to explore and understand. The outcome of this race could dramatically reshape global power structures and supply chains, influencing everything from geopolitics to the price of everyday electronics. But this rush for riches comes with serious risks. Mining the deep sea could disrupt fragile ecosystems, threaten unknown species, and create environmental challenges we don't yet fully understand. As the world watches and debates, the next chapter of the gold rush is being written, far beneath the waves, at the bottom of the world. The deep ocean is not a barren wasteland. It's a unique, fragile ecosystem teeming with life found nowhere else. Many deep-sea creatures are slow-growing and long-lived, their habitats shaped over millions of years. Deep-sea mining threatens to destroy these habitats, wiping out species before we even discover them. Massive robotic vehicles would scrape the seafloor, creating sediment plumes that could smother life for miles. Mining could also release toxic metals, disrupting food webs and potentially harming the entire ocean ecosystem. The deep ocean is a vital carbon sink, helping regulate Earth's climate. Disturbing the seabed risks releasing stored carbon, undermining the very climate goals these minerals are meant to support. We know more about Mars than our own deep sea. The environmental cost of mining could be irreversible. Are we ready to risk the unknown for the promise of progress? The International Seabed Authority, or ISA, governs this new frontier, tasked with balancing resource extraction and environmental protection. The ocean floor beyond national borders is considered the common heritage of humanity. Some nations, led by China, push for rapid mining to fuel the green transition. Others, including France, Germany, and Pacific Island nations, call for a moratorium until we better understand the risks. The debate is fierce. Should we mine now or wait for science to catch up? The ISA's decisions will shape the fate of the deep sea and our planet. The world stands at a crossroads. The quest for deep-sea minerals is now a stage for global power struggles, especially between the US and China. Science-enabled collaboration, but the outcome has fueled new strategic rivalry. The US wants secure supply chains for its clean energy future, but China's lead in deep-sea mining is a growing concern. Ironically, the US hasn't ratified the UN Convention on the Law of the Sea, limiting its influence at the International Seabed Authority. Control over deep-sea technology also means greater maritime power. The race for minerals is tied to the broader contest for control of the world's oceans. The struggle beneath the waves is shaping the balance of power above. The next chapter of sea power is being written in the abyss. We stand at a crossroads. Our ingenuity has revealed new resources, but also new risks. Satellites and open science led to a discovery that could power a cleaner future. Yet the same minerals that promise a green revolution could devastate a pristine world beneath the sea. The debate over deep-sea mining is a test of our wisdom and responsibility. Do we embrace this new frontier, trusting technology to minimize harm? Or do we pause, protecting the deep ocean as a common heritage? The choice is ours, not just for governments, but for all of humanity. The path we choose will define our legacy as stewards of this planet. The cosmos is watching,